Gold bars may look valuable, but their journey begins deep inside ordinary rock. Hidden within quartz veins and ancient geological structures, gold can remain trapped for millions of years. Before it becomes a precious metal, it must pass through a remarkable extraction process. From discovery and mining to crushing, processing, and refining, every step plays a crucial role. Few people ever see what happens between a gold-bearing rock and a finished gold bar. Today, we're uncovering the complete journey of gold, from deep within the earth to the shining bars stored around the world.
Gold changes the way people think, not because it glows, not because it's expensive, but because of what it represents: wealth, power, security. For thousands of years, civilizations crossed deserts, destroyed mountains, and built entire economies around one metal. And yet, even today, one fact still surprises people. Most gold does not begin as visible treasure. It begins hidden, locked inside ordinary-looking rock. Not sparkling, not obvious, not sitting on the surface waiting to be picked up. Buried inside structure, disguised by stone, invisible to almost everyone. And that raises a question most people never stop to think about. If gold is trapped inside rock, how do professionals actually remove it? Because extracting gold is not one action. It is a chain of controlled steps, each stage solving a different problem. Break the structure, reduce the material, separate the heavy minerals, dissolve the hidden gold, recover it, purify it, then finally transform it into metal. And the deeper you go into this process, the stranger it becomes. Because the rocks people ignore every day can eventually become molten gold bars. Today, we're breaking down the entire system, step by step, from ordinary rock to extracted gold. And once you understand how the process works, you will never look at rocks the same way again. Step 1. Why gold hides inside rock. Before extraction begins, you first need to understand something critical. Gold is almost never found the way movies portray it. Huge exposed nuggets? Rare. Bright yellow veins sitting openly on the surface? Uncommon. The reality is much more deceptive. Most gold is microscopic. Tiny particles trapped inside quartz veins, sulfide minerals, fractured host rocks, and mineralized systems formed deep underground. And the reason gold ends up inside rock begins millions of years earlier, far beneath the Earth's surface, long before humans existed. Superheated fluids moved through fractures underground. These weren't ordinary fluids. They carried dissolved minerals, quartz, iron, sulfur, and gold. As pressure changed and temperatures dropped, those fluids began depositing minerals inside fractures, layer after layer, over immense periods of time. That's how gold-bearing systems form, not instantly, but through geological transport. And once gold becomes trapped inside solid rock, it becomes difficult to access, because rock acts like a locked container. Everything inside is sealed, every fracture compressed, every mineral grain trapped together. Which means extraction is not about finding visible gold. It's about destroying the structure hiding it. That changes the entire way you think about mining, because the real target is not the gold itself, it's the rock surrounding it. And that leads directly to the first major stage. Step 2. Crushing the rock. At first glance, crushing rock sounds simple. Hit the rock, break the rock, collect the gold. But real extraction does not work that way. Because breaking rock once changes almost nothing. The gold remains trapped, still sealed inside fragments, still inaccessible. Which means crushing is not about damage, it's about reduction. Professionals begin with primary crushing. Large rocks enter powerful crushers designed to reduce massive pieces into smaller fragments. The goal here is not liberation. The goal is manageable size. Think about what happens physically. A large quartz-rich rock enters the crusher. Pressure builds. The rock fractures along natural weak points. Pieces break apart. But inside every fragment, gold may still remain trapped. So the process continues. This is where the first misconception disappears. Gold extraction is not one violent action. It is controlled destruction. And control matters, because if material sizes become inconsistent, problems begin immediately. Some fragments stay too large. Gold remains locked. Other sections become too fine too early. Valuable material risks being lost. Step 3. Grinding the material into powder. Crushing alone is not enough, not even close, because large fragments still contain locked minerals, gold trapped between quartz grains, microscopic particles bonded inside sulfides, hidden zones untouched by primary reduction. So the material moves into the next phase, grinding. This is where extraction becomes serious, because grinding changes the behavior of the entire system. Large fragments become gravel. Gravel becomes sand. Sand becomes powder. And once rock reaches powder consistency, something important happens. Minerals begin separating from each other. That changes everything. Because gold is no longer trapped inside a solid structure. Now it exists as individual particles, free, potentially recoverable. But reaching this stage is harder than most people realize. Grinding requires enormous energy. Industrial mills rotate continuously. Steel balls crash into rock repeatedly, hour after hour, reducing material further and further. And here's the critical balance. Too coarse, gold remains locked. Too fine, recovery becomes difficult, especially fine gold. Professionals understand this balance with extreme precision, because every ore type behaves differently. Quartz-rich ore crushes differently than sulfide-rich ore. Hard rock behaves differently than oxidized material. Some gold particles separate easily, others remain stubbornly attached, which means extraction is never completely identical between mines. Every system must adapt. And this is where geology starts controlling engineering. The rock itself determines how extraction proceeds. Now think about the scale. An ordinary-looking rock enters the mill. Hours later, it no longer resembles stone at all. It becomes powder, a cloud of crushed mineral particles. And hidden inside that powder is gold. Still invisible, but now physically separable. Which leads directly into one of the oldest extraction principles ever discovered: gravity. Step 4. Why gold sinks. Gold has one enormous advantage: density. It is dramatically heavier than most surrounding minerals. Quartz, light. Sand, relatively light. Clay, light. But gold, extremely dense. And this difference allows separation, not visually, physically. This is where gravity concentration begins. One of the oldest methods humans ever used to recover gold. Long before modern chemistry, long before industrial cyanide systems. People already understood one thing: gold sinks. Now imagine powdered rock mixed with water. Movement begins. Lighter particles stay suspended longer. Heavier particles resist movement. and gold naturally migrates downward. This principle powers multiple systems: gold pans, shaking tables, spiral concentrators, sluice boxes, each designed to exploit density differences. But here's the important detail most people miss. Gravity concentration does not magically create gold. It isolates heavy material, which means efficiency depends entirely on preparation. If crushing failed, gravity fails. If grinding failed, gravity fails.
Because gold still trapped inside rock behaves like rock, not gold.
This is why liberation matters so much. Once free, gold finally begins behaving differently. And now the extraction process becomes visible. Heavy concentrates begin appearing, black sands, dense mineral mixtures, metallic particles. And somewhere inside those concentrates, gold begins accumulating. But the system is still incomplete, because gravity alone cannot recover everything, especially microscopic particles. And that's where modern extraction takes a dramatic turn. Chemistry. Step 5. The chemical stage. This is where gold extraction becomes controversial, because gravity works well for larger particles. But microscopic gold creates a different problem. Some particles are too fine, too deeply embedded, too chemically attached, which means physical separation alone leaves gold behind. And in mining, leaving gold behind means losing money. So professionals developed another solution: leaching. Now listen carefully. This stage completely changes the process, because instead of separating gold physically, the system dissolves it chemically. That sounds impossible at first. Gold is famous for resisting corrosion. It survives centuries underground. It barely reacts to oxygen. It resists destruction. So how do you dissolve it? Cyanide. When processed correctly under controlled industrial conditions, cyanide solutions bond with microscopic gold particles. The gold leaves the rock and enters solution. This is one of the most important breakthroughs in mining history, because suddenly, gold no longer needed to be visible to be recoverable. Tiny invisible particles became economically valuable. Entire low-grade deposits became profitable, and modern gold production exploded. But here's the part most people misunderstand. The cyanide does not melt the rock. It targets the gold, which means preparation still matters. If the ore was not crushed correctly, solutions cannot reach hidden particles efficiently. If grinding failed, gold remains trapped. Again, every stage depends on the previous stage. That's what makes extraction fascinating. It is not one machine, not one chemical, not one secret. It is a sequence, a chain. And if one link breaks, recovery drops immediately. Now imagine giant industrial tanks, crushed ore mixed into slurry, pipes moving chemical solutions continuously, millions of microscopic gold particles dissolving silently into liquid. At this stage, the gold is no longer inside rock, but it still is not visible. It exists dissolved inside solution. And now another question appears. How do you get dissolved gold back out? That's where recovery begins. Step 6. Activated carbon and the invisible capture. This stage feels almost unreal because the gold cannot be seen. Not yet. It exists dissolved in liquid, invisible. And yet industrial systems can still recover it. How? Activated carbon. Tiny carbon particles capable of attracting dissolved gold compounds. Think about what's happening. The gold left the rock, entered solution. Now it transfers again, from liquid to carbon. Professionals circulate activated carbon through large tanks. As slurry moves, dissolved gold bonds to the carbon surface, slowly concentrating. This stage is extremely important because gold recovery efficiency determines profitability. A small percentage loss across massive tonnage means enormous financial loss. So recovery systems are optimized constantly. Temperature, flow rate, chemical balance, retention time, everything matters. And now, something fascinating happens. The carbon itself becomes valuable because it now carries concentrated gold. But the gold still isn't visible, not as metal, not yet. That transformation comes later. First, the gold must be stripped from the carbon. Step 7. Stripping the gold back out. Now the system reverses direction. Earlier, gold moved from rock into solution, then from solution onto carbon. Now professionals remove it again. This is called stripping. Specialized systems separate gold compounds from activated carbon using heat and chemical treatment. And once complete, the gold enters concentrated solution once again. Except this time, the concentration is dramatically higher. The process is narrowing, step by step, removing waste, increasing purity, focusing the metal. And this is where many viewers suddenly realize something surprising. Gold extraction is not one dramatic discovery moment. It is refinement, continuous refinement. The entire process is designed to eliminate everything that is not gold. Rock removed, light minerals removed, waste slurry removed, chemical impurities removed, until eventually, almost nothing remains except concentrated metal. And that's when the final industrial stages begin, the transformation from dissolved particles into visible gold. Step 8. Electrowinning. This is where science starts looking like technology from another era. Electricity now enters the process. The concentrated gold solution moves through electrowinning cells. Electrical current passes through the system, and gold begins depositing onto metal plates. Slowly, silently, particle by particle. Think about what just happened. Gold that once hid inside solid rock underground is now accumulating because of electricity. That transition alone feels unbelievable. But the process is still not complete, because the recovered material is not pure gold yet. It exists as sludge, a dark metallic concentrate containing gold alongside remaining impurities. Not beautiful, not shiny, not what most people imagine. And yet, this sludge may contain enormous value. Millions of dollars concentrated into industrial residue, which leads to the final dramatic stage, fire. Step 9. The furnace. Everything now changes. For the first time in the process, gold becomes visible as metal. The sludge enters a furnace. Temperatures exceed 1,000 degrees Celsius. Extreme heat liquefies the concentrate. Impurities separate. Flux materials help remove unwanted components. And slowly, molten gold begins forming. This is the moment people recognize. Bright molten metal glowing inside industrial furnaces. Heavy liquid gold pouring into molds. And when it cools, the result is a doré bar. Not fully refined investment-grade gold yet, but real metal, recoverable wealth, extracted from rock most people would never notice. And that realization changes how you look at the ground forever. Because hidden beneath ordinary landscapes, These processes are constantly waiting to begin. Gold extraction sounds simple when reduced to one sentence: break rock, get gold. But the reality is far more complex. Every stage solves a different problem. Crushing removes structure. Grinding liberates minerals. Gravity isolates density. Chemistry dissolves hidden particles. Carbon captures value. Electricity concentrates metal. Fire transforms it. Gold is often viewed as something that requires fancy machines, toxic chemicals, and a lot of luck. But what if I told you the best gold tools are already right under your feet? No acids, no expensive equipment, no overcomplicated processes. Just nature's gold tools, from rivers and rocks to the force of gravity and the steady hand of time. In this video, we're diving deep into why the smartest prospectors don't rely on the latest technology or hazardous chemicals. They trust nature itself. And here's the secret that most people miss. Nature has been guiding us to gold for millions of years. It's been quietly shaping the land, pushing the gold in directions we can track, if we know what to look for. Let's face it, gold doesn't just appear out of nowhere. It follows a pattern, a path, a natural order. This is where geology and nature's blueprint come in. Gold is transported by powerful underground fluids, carried through fractures and structures you'd never see, unless you knew the signs. In the next few minutes, I'll show you exactly how rivers, rock formations, and even gravity act as nature's invisible gold map. When most people think of finding gold, they picture massive machinery or complex extraction methods. But the truth is, the most successful prospectors know how to read the land, how to recognize the clues that nature has already laid out for them. Here's a question for you. Have you ever looked at a riverbed and thought, that's just dirt and rocks? Well, think again. Rivers, over millennia, don't just move dirt. They move gold. Through the forces of erosion, water flow, and gravity, rivers naturally concentrate gold into certain spots. The heaviest material sinks to the bottom, leaving you with rich pockets of placer gold where the current slowed down. And guess what? The same applies to the rock patterns you see in the mountain slopes, riverbanks, and stream beds. The right rocks can tell you exactly where gold is hiding. Fractured quartz, iron-stained veins, and layered formations are all natural clues. Nature's map that leads you to treasure. Here's the thing. Gold doesn't just hide in shiny rocks. In fact, some of the best gold-hosting rocks look far from impressive. Fractured rock, rusty surfaces, dull iron staining. These aren't just ugly rocks. They're gold's favorite hiding spots. When the earth is pushed, folded, and cracked under pressure, it opens natural pathways for gold to travel through. These fractures trap gold in microscopic particles, and once you know what to look for, those dirty, broken rocks suddenly become gold maps. What does this mean for you? The next time you walk past a creek, an exposed mountain face, or a barren riverbed, ask yourself, what's hidden beneath the surface? Gold doesn't sit on top. It settles. It waits to be found, trapped within the rocks. This is where things get fascinating. Gravity is gold's silent partner. Over time, the gold carried by rivers and fluids settles in specific spots where the flow slows. Lighter materials get carried away, but heavier gold drops in the right places. Look at gold-bearing rivers and you'll often find the heaviest concentrations around natural bends, drop zones, or places where water flow decreases. These are gold traps, and once you learn how to spot them, you're not just looking at rocks or water anymore. You're tracking gold. Now let's talk about time. Time is gold's ally. Gold didn't just appear overnight. It was carried, moved, and deposited over millions of years. Every time a river flows, every time the earth shifts, gold settles deeper into the ground. Time shapes everything, from how gold deposits form to where it ends up. This is why old riverbeds, ancient fault lines, and weathered rocks hold so much potential. Over time, the earth has pushed, pulled, and sorted the gold for you. Now the exciting part. You don't need expensive equipment to find gold. You need a keen eye and an understanding of nature's systems. By reading the land, recognizing the geological clues, and understanding how gold naturally travels, you can step into the world of professional prospecting without relying on machines, chemicals, or guesses. It's not just about finding gold. It's about investing in the right opportunities. Smart prospectors don't just look for gold. They understand where it's most likely to be. And once they find it, they turn it into long-term value, sometimes just by using the very natural resources that led them there. Ready to discover gold? Start with nature. Don't wait for a fancy machine or chemical extraction. Nature's already giving you the tools. Your job is to read the signs. Let the ground speak to you, and you'll understand exactly where to look next. And remember, gold is not just about shining rocks. It's about structure, pressure, and time. So start thinking like a pro. The treasure is right under your feet. We uncovered how gold doesn't just appear randomly. It follows geological pathways and structures created by nature itself. Now it's time to take these clues and turn them into actionable gold prospecting knowledge. We've talked about the land and the rocks, but now let's look at water, specifically rivers and streams. Rivers are gold's highway, where gold is carried from its source to its destination. But here's the catch. Gold doesn't travel far without leaving a trace. Every twist and turn of the river holds gold traps, and if you know where to look, you could be standing just inches away from treasure. Gold's density is its biggest advantage. It sinks faster than other materials. So, in a river, when the water slows down, gold drops to the bottom. And not just anywhere. It concentrates in specific spots, forming pockets of placer gold. Think about it this way. Gold doesn't just get swept away by the current. It moves according to the water's flow and speed. In places where the water slows down, like behind boulders, around curves, or in deeper pools, gold will settle. Old riverbeds, once rich in gold, can now be gold mines, if you know how to read them. Let's take a step back and talk about the old school way of finding gold, the method that still works today. Panning. Panning is simple. It doesn't require expensive equipment or a degree in geology. It requires patience and a keen eye. The goal isn't to rush, it's to work with nature. To pan for gold, you need a pan, water, and dirt, or more specifically, sediment from rivers or stream beds. The trick is to allow the gold particles to settle to the bottom of the pan. Here's the catch. The heavier the gold, the quicker it sinks to the bottom. The lighter materials, like sand or gravel, wash away. But even with something as simple as a pan, success doesn't come from blind chance. It comes from knowing where to look. You need to search the right spots where gold has had time to accumulate. Now that you know the basics of panning, the next question is, where do you pan? This is where geological patterns come into play. Remember when we talked about fractures, folds, and faults? These aren't just geological features. They're gold highways. Wherever there's been pressure, movement, or heat, there's a good chance that gold has settled in those areas. Look for shallow rivers, deep pools, bends in the water, and rocks that create natural barriers. These spots slow down the current and let gold settle. And while panning might seem like a slow process, in the right spot, it can be incredibly rewarding. Understanding how gold is deposited is just as important as knowing how to pan for it. So when looking for gold, think of the history of movement. Follow the flow of ancient rivers, the fractured rock that once held the fluid, and the places where gold would have naturally settled. These areas of movement are often rich in gold deposits, whether in the form of placer gold in rivers or veins of gold-bearing quartz in the hills. As we wrap up today's exploration, here's the key takeaway. Gold is not hidden by chance. Nature has designed its path. Gold moves through the earth, leaving clues in the landscape, the rock, and the riverbed. The real question isn't, where is gold? The real question is, where can gold exist? The ground is speaking, the rivers are whispering, and the rocks are telling you where gold might be. Now, all you have to do is listen and follow the clues.